This is part 3 of the predictive move system, which is the final one, so make sure to watch the previous 2 parts first if you haven't. I will now create a test map to test and showcase all the features. This is not required for the actual tutorial, so you can skip to the time shown. It will however cover how to use each blueprint in detail, and especially with other meshes, which are from Quixel Bridge. If you have meshes that will be repeated multiple times, you can make a child blueprint of that particular type and add the mesh there so it can be reused. Here I am using a longer mesh for the jump point, so the use spline is being enabled. If you are using any meshes from Quixel Bridge for this, then ensure that you open the mesh and add any form of suitable collision for it before adding it to the movable object, otherwise it will not be detected by the traces. Here I am adding meshes for jump points that are not that wide, so they are not using splines. The land pause and height pause can be adjusted for each based on the mesh. This is an example of using a mesh for vaultable objects. The splines can be adjusted easily to update for this new mesh. Finally is swingable objects. I will use this bar mesh and adjust the scale and rotation so it follows the default spline. The spline or mesh can then be adjusted to be as long as you want. Sometimes the mesh may not be pivoted correctly, so you can very easily adjust them to be in the center using Unreal Engine 5's modeling mode. You can adjust it in the X-form category by selecting Edit Pivot, then pressing Accept when ready. Making child blueprints for reusable meshes also allows you to add any extra unique components such as these end pieces being added to this modular rope. I will add a section for beam walking as well, which will be part of the bonus integration section along with ledge climb detection. I will now test the system, fix bugs and add the final feature, which is the swinging hand IK. The player is moving to jumpable points correctly and based on the input direction. There are some problems with the big jump. First go to this greater than and change the value to 300. Then open the big jump montage and adjust the second motion warping notify to be longer. This is since this animation was not going directly to the land point but a bit behind. You can adjust the motion warping times until it fits perfectly for you, but it may include a lot of trial and error. The mantle jump animation also won't trigger unless the positioning is correct due to the values we input. You can either adjust your level design or the threshold value for mantling to occur. Now mantling is working. The big jump animation is also landing in the center now. The next bug is that the player is getting stuck sometimes and not moving despite there being input. To fix this, go to the Get Closest Actor to Camera function. Change this error tolerance to 0.002. Then go to the Predictive Move Has Gap function. Make some space at the end. Break the hit result and check if the hit actor implements the movable object interface. Add a not operator and make this another condition in the end. It is working perfectly now. Next is an issue with the exiting code. I forgot to add another branch here. If this branch is true, add another one that checks play exit animation. If true, continue the code. If false, set the onPredictive point to false, removing it from the other branches false. Then go to the exit predictive move trace and make an array for this trace's actors to ignore. The element should be the current closest actor. Then go to the exit predictive move macro and set the predictive move exit held time to 0 before the motion warping nodes. Set it to 0 in completed for the move enhanced input as well. This is to reset the held time for the next time the player tries to exit. The player now plays the falling animation if you try to exit where there is no floor. If there is a floor, it plays the small jump animation and lands there. If play exit animation is unchecked, the player will just walk off as usual when the exit time is reached. Next will be issues with the landing position detection. Here the player swings and should land on the floor but is landing on the vaultable object even though it is pretty far away to realistically land there. To fix this, go to the predictive move land trace function. Remove the set closest predictive actor. Then add a branch after the get land position. Get the distance between the land position and closest predictive actor location and check if it is greater than a value like 400. If false, continue the code. Set the hit actor output for this path to the get closest actor to camera output. If the branch is true, connect it to the exit predictive move trace. The player is now landing properly. If the vaultable object was closer, they would land on that. Going from vaulting to swinging to a jump point works perfectly as well. Now will be some general fixes. Go to the step up animation and adjust the second motion warping to finish earlier. Change the predictive move max amount to 475. These values can be fine-tuned to your liking. We will now do the hand IK for swinging. Go to your character's animation blueprint. I will collapse this code from the previous mechanic. In the event blueprint update animation, first get a reference to your character blueprint. Get the predictive hand IK locations for each hand and promote them to variables. Then make a float variable called swing hand IK alpha and a boolean one called swing hold. Set the IK alpha to an F interp2 with the current being the value of it. The target is swing hold. It will automatically create a boolean to float if you drag it in. The delta time is the world delta seconds and set interp speed to something like 10. A higher value means faster blending. Now add the swing hold notify we made at the start. Set swing hold to not of the current value. This correctly enables and disables it during the swing animation. Now go to the anim graph. Again, yours will look different if you have not followed along for the other videos. Go to the very end and add a 2-bone IK node. Change the IK bone to hand_L. Set allow stretching to true and allow twist to false. Change the effector location space to world location as we are using the location from the swingable objects in world coordinates. Finally, set joint target location to bone space and set the joint target to lower arm_L. The alpha should be swing hand IK alpha and the effector location is the predictive hand IK left location. Set the joint target location to -15, 2, 5. If you are using a different mesh not similar to the default mannequin, you may need to play around with this value. Duplicate it and replace where necessary for the right hand. Hand IK is working perfectly and looks realistic in game now. With all the mechanics done, we will do the final bug fixes. First, go to the Reset Predictive Move event. Set has predictive jump to false after the was new type detected. Then go to the Predictive Move macro. Call Reset Predictive do once as well here. Next, go to the Predictive Move land trace function. Delete this subtract from the exit trace as it made the player go through the floor when the vault over animation played. Next, we will adjust the detection for the land position. Duplicate the get closest actor to camera, replacing camera with player. Adjust the nodes as shown. This finds the closest object to the player instead, since the landing should be based on the current character path instead of the camera. Replace the get closest actor to camera here with the player one. Then change this value to 520. Again, values like this can be trial and errored with to find the best one. Next, we will fix the camera going through swingable objects. Go to the movable object blueprint. At the end of the construction script, add a set collision response to channel with the channel being camera. For the response, add a select node with the index being a Boolean variable called ignore camera collision. If false, set it to block, and if true, leave it at ignore. Set ignore camera collision to instance editable as well. Go to the swingable object blueprint and set the default value of it to true. The jumpable object has multiple dynamically selected animations as shown. All these meshes work perfectly as well. Vaulting works accurately and the player lands on the jump points. The animations for this are randomly selected in the array we declared. Swinging also works with no bugs now. Here is a list of some suggestions you can add on which were omitted from the video due to the length. That is all for the main tutorial. I will now show how to integrate it with the rest of the Parkour series if you have followed along for them. If not, then thanks for watching. For the beam walking integration, first open the movable object type enum. Add a type called beam. Then open the beam actor and add the movable object blueprint interface to it. In the construction script, select the add spline mesh and set the collision response of move point in it to block. Open the getType BPI function and change the type to beam. Then open getPeakPosition. Copy the nodes shown. This is similar to what we did in the jumpable object by finding the closest position on the spline. Go to Get Land Position and copy these nodes. Next, open the player blueprint. Go to the Predictive Move macro. After the set timer, add a branch that checks is on beam. If true, call on beam exit before continuing to the output, and if false, then go directly to the output. Now go to the start of the movement input code for predictive move. Add a new branch that checks is on beam and continues only if false. This is since we don't want to predictive move on a beam unless we try to move away from it. Go to the exit predictive move part. For this condition, add an operator which checks not of is on beam. Go to the beam walking code. In this branch, call reset predictive move if false. Make sure to connect beam on the switch onto the same as the jumpable. This is since beam walk points are moved to with the same animations. Predictive moving to a beam is working now. If at the end of a beam you can predictive move off it, you can also land on a beam after swinging. Exiting works as normal when you reach the end of a beam. Next will be ledge climbing integration, which will only be one node. Call the ledge climb input event on jump and notify begin for the swingable path. I will add a new block for ledge climbing as I have the ledge climb masking option enabled. The player can now go from swinging to ledge climbing. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.